Never before had we witnessed the sun with such resolution, nor had we come so close to our guiding star. In this space odyssey, powerful solar flares, amazing views of the solar poles, and a curious solar herd have been captured by telescopes and space probes, such as the Solar Orbiter and the Parker probe, which ventured less than 8 million kilometers from the Earth, fiery heart of the solar system. From our planet, the vision of the sun has always been veiled by its immensity and radiance. Today I invite you on an unprecedented journey to discover the true nature of our star. That gigantic nuclear furnace in which all life on Earth finds its origin and energy. Prepare to be amazed, because what you will see is more impressive than you ever imagined. But we will not stop there. Beyond mere observation, I will take you one step closer, more intimate. I will show you unpublished images, some without the usual filters, so that you can experience the feeling of being right there, at the closest distance we have ever reached. Today, in a bold act of exploration, you will be able to touch the sun. In ancient civilizations thousands of years ago, they had various beliefs and mythologies about the sun. Almost all of them agreed that the sun was a deity, and that they should worship it. With the development of astronomy, it was understood that the sun was a star and that the earth revolved around it. The first person to suggest that the sun was a star was Anaxagoras, more than 2,400 years ago. He suggested that the sun was a mass of hot iron and that the other stars were too far away for us to notice their heat. Because of his scandalous ideas for the time, he was imprisoned. In the 19th century, stellar theory was developed and spectroscopy was developed. Then the chemical composition of stars began to be understood. Astronomers observed that the stars were similar to the sun in terms of chemical composition, which suggested that the sun was indeed just another star, but it was much closer than the others. The sun is a star that is located in the center of the solar system, although it seems like it is a ball of fire. The truth is that it is an almost perfect sphere in a plasma state. Plasma is another state of matter and the most abundant in our universe. On our planet we can see plasma in lightning, fluorescent lights, in arc welding and other processes. Unlike solids, liquids and gases that are made up of neutral atoms or molecules, plasma is made up of charged particles, such as electrons and ions. These charged particles make the plasma exude unique properties. This hot sphere is composed mainly of hydrogen and helium, which emits light and heat due to nuclear fusion in its core. Nuclear fusion is a process in which nuclei combine to form helium, releasing a large amount of energy in the form of electromagnetic radiation, including visible light, ultraviolet radiation, and X-rays. This energy is what provides light and heat to objects in our solar system, which allows the existence of life on Earth and keeps the planets moving around it due to gravity. The Sun is a main sequence G25 spectral type star, meaning it is a yellow dwarf star, according to the Hertzsprung-Russell diagram. Although the Sun appears to be white to the naked eye, its classification as a yellow dwarf does not directly refer to the visible color that we perceive from Earth. This classification is based on the temperature and composition of the light emitted by the star. It has a diameter of approximately 1.4 million kilometers, which is about 109 times the diameter of the Earth, and its surface temperature of around 5,500 degrees Celsius. Although for a long time we thought that the Sun was a common star, the truth is that it is quite rare. Only 10% of the stars in the galaxy are yellow dwarfs, and their energy is essential to maintaining life on Earth and for the climatic and geological processes of our planet. Before giving way to the most impressive photographs of our star, we must understand the structure of the Sun in order to be able to interpret it. This is the corona. It is the outermost layer of the Sun and extends into space almost 1 million kilometers thick. The corona is visible during a total solar eclipse and is much hotter than the photosphere, with almost 2 million degrees Celsius, possibly caused by the Sun's magnetic field and Alfvén waves, which manifest as disturbances trapped in that area. The chromosphere is a thinner, hotter layer just above the photosphere. This is where phenomena such as solar prominences and solar flares are observed. The photosphere is the visible layer of the Sun that we observe from Earth. It is a relatively thin layer and is the coldest part of the Sun. The photosphere emits most of the Sun's visible light. The radioactive zone, This is the layer found just above the core. In the radioactive zone, the energy generated in the core is transported outward in the form of electromagnetic radiation, mainly photons of light. Above the radioactive zone, the Sun has a region known as the convective zone. In this layer, energy transfer occurs mainly through convection, where hot gas bubbles rise to the surface, releasing energy in the process. And this is the core. Nuclear fusion reactions occur that are responsible for the generation of solar energy. With up to 15 million degrees Celsius, and allows hydrogen nuclei to fuse to form helium through nuclear fusion processes, which release an immense amount of energy in the form of light and heat. Scientists have managed to capture surprising images of the Sun, the fiery star at the heart of our solar system. These images reveal the surface of the Sun, known as the photosphere, as well as a close-up of sunspots. These most recent photos were taken by the Daniel K. Solar Telescope, Inouye, a colossal instrument located at the Haleakala Observatory on the island of Maui, Hawaii. The images have various yellow filters that attenuate the sunlight to see their surface. This telescope is the largest in the world, specially designed to study the Sun with an aperture of 4 meters. It looks like a bee's honeycomb. Each of these photos covers about 82,500 kilometers. Here you see the Earth in perspective. These other images provide a unique view of the Sun and allow us to observe the movement of solar plasma, detailed characteristics of sunspots and convective regions. These photographs are the result of the work of researchers who work hard to better understand our king Astro and its influence on our planet and the solar system as a whole. These images are not only impressive in their beauty, but also shed light on the immense magnitude and power of this cutting-edge telescope, which allows us to explore in detail one of the most important phenomena in our universe, the Sun. The Solar Orbiter Space Probe has given us a spectacular image of our star. This amazing capture is made up of a mosaic of 25 images, which when combined create a stunning photograph with 83 million pixels, using a wavelength of 17 nanometers. ESA claims that this is the highest resolution image ever taken of the entire disk of the Sun and its corona or upper atmosphere. At the time the image was taken, the solar orbiter was about 75 million kilometers from the Sun, located approximately halfway between Earth and our star. Launched in February 2020, the solar orbiter probes follow a series of eccentric orbits that will bring it closer and closer to the Sun, allowing detailed observations to be made with the onboard instruments. The most surprising thing about this image is that the European Space Agency has included a small dot in the upper right that represents our planet in relation to the size of the Sun. The entire image has dimensions of 9148 by 9112 pixels, and the ESA provides an interactive graphic that allows you to explore the image as you wish, zooming in and out. In the coming years, the probe will continue to get even closer to the Sun and will gradually vary its orientation, which will allow us to observe the polar regions of our star for the first time. We have also captured small solar bonfires never before seen on its surface. They are much smaller than common solar storms observed from Earth, and could be related to the mystery of solar corona heating. The bonfires are a couple of pixels and approximately 400 kilometers. That is our resolution. METIS is a special instrument of the solar orbiter waves, which blocks bright light from the Sun's surface, allowing us to observe the star's tenuous outer atmosphere. These extraordinary images present bursts of charged particles and can interfere with satellites and radio communications. These curious photographs of the Sun are taken by ALMA, the most powerful radio telescope in the world. These other photos show the Sun at a particular wavelength of light, known as Lyman alpha, where hydrogen can be identified in the Sun's lower atmosphere, the chromosphere. Here the temperatures are of the order of 10,000 to 100,000 degrees Celsius. The Parker probe is a specialist in studying the solar corona and has also captured impressive images of the Sun, just 7.26 million kilometers away, closer than any other human object, and at an astonishing speed. During its observations, the probe has detected small flares called jetlets, which contribute to the energization of the solar wind. This discovery overturned previous understanding and shows that the solar wind forms from multiple small explosions, rather than breaking off smoothly from the solar corona. In addition, the Parker probe has witnessed the enormous ejections of massive coronas from the Sun, which expel particles at high speeds. These events reveal the violence of the Sun and provide valuable information about how energetic particles move at nearly the speed of light. All of this is related to the constant interaction of magnetic forces in the Sun, which drive solar events to affect the Earth. Here we see impressive coronal streamers, massive loops of electrically charged gas and plasma. Imagine yourself descending into the Sun with armor so strong that nothing can harm you. Without filters, we discover that the Sun is actually white, and to appreciate it, we must decrease the brightness intensity millions of times. It looks like an incandescent sea, but it is plasma. A state of matter so peculiar that if we could touch it, you would notice a dense and compact gas that we can pass through without difficulty. We contemplate and wonder the great eruptions with a spectacle as dazzling as no human being will ever be able to contemplate. In our quest for knowledge, we have learned that the Sun is much more than just a source of light and heat. We discover its enigmatic nature hidden behind its powerful blinding light. We have explored its fiery surface and its incandescent corona, challenging the boundaries of the known and the unknown.